And here we are right now with Node.js, specifically on GraphQL section. Okay, so quick recap. GraphQL is a new query language. It's a new way of building front-end and back-end applications. So the beauty of this is that we can see how all of the different pieces of data relate each other in our server. So with GraphQL, it all starts by describing our data using schemas, and we want to ask for data, we rely on queries. And queries are much like selecting property on an object. That the great thing of this is, since the query really match closely the return objects, we can predict what our query would return. So including is the property fields, regardless how the data is stored, whether it's being used in a document base, uh, relational database, key value, graph, or white column. So this is something that was created by Facebook in 2012, and it solved two main issues that come from RESTful architecture, something called overfetching and underfetching. Underfetching means that we lose time making additionally and sometimes unnecessary requests to the server, querying multiple collection of value, thus increasing the page load time. And the overfetching is the server now send additionally extra and unnecessary data to the client, so we need to filter out to show relevant information to the user. So GraphQL solves this issue by just having one single entry point, and also with a GraphQL query, we just ask for the data that we want. And these GraphQLs allow us to query multiple type of data. So I saw, for example, is the specification website for GraphQL. Also, how can you use GraphQL with React framework? For example, relay.dev, right? And to build more high-end products, or for building front-end and back-end GraphQL servers, we can use something called Apollo GraphQL. Great. So I started to look at how can I solve this GraphQL and the benefits of using GraphQL, which is, well, no more underfetching, no more overfetching. You have schema and types, which makes your GraphQL API documents. You already have a document API, and also speed up the development process. The trade-off is that because this flexibility adds complexity, since this is a new way of building these front-end and back-end applications, and since it is not REST, which is a architectural design that has been over the past decades. So we have this steep learning curve with knowing how to create a GraphQL service. Also, that catching is something difficult, because with RESTful we already have proven catching methods, but now we have this new way of doing things. So even though I saw how can I create GraphQL queries from scratch, and see the benefit of using is the graphical, this built-in front-end tool for testing GraphQL queries, and see how that works behind the scenes, all right, by using its tools like Postman and Insomnia that allow you to test endpoints, and underneath the hood is using its HTTP internet or this HTTP protocol to send an HTTP post to that GraphQL endpoint. So then I look at how can I create GraphQL server from scratch, okay, at least to get a simple example to illustrate what a GraphQL server uh, is, or what a GraphQL server are, by using its Node expressed as a web server framework and using it as an express middleware for GraphQL, and also is the GraphQL package. So define is the particularly type system where you describe is all the capability that this GraphQL server has, uh, and then take a look at more realistic example when you are designing for demo purpose an e-commerce app. So the great thing of setting an e-commerce is that really nested objects are fairly common in any uh, e-commerce application or any application with some technical debt. You might find in almost any industry, uh, and yeah, with that, so I define is and what I design is an e-commerce. Following is from an example from the uh, Node.js course from Zero to Mastery Academy here. That's right. The GraphQL section. Exactly. That's right. Uh, we're gonna look at here the my notes from GraphQL server is here. Okay, so I design is this e-commerce. You see how can I create this and how can I describe the capability of this GraphQL uh, and also see quickly that if you want to make your GraphQL server maintainable, meaning that you want to organize your server by per features, and if you want to add more complex logic to fetch data, it is important to rely on tools such as GraphQL tools to scale your application, so to modularize your application. So I start doing that with schemas, okay? So by looking at the type definition and break your types or break the schema per functionality into multiple files using a .graphql file, right? And if you want to load all of those files, you rely on a function from these GraphQL tools, a set of utility for building GraphQL schemas and for help us to maintain GraphQL server, and using a function called makes executable from the GraphQL that allows you is to import all of your types in a string as an array, right? So calling function like load file sync, which it will hold the executions For example, here, we get this here. So calling file functions like load file sync will hold the execution of this server, look out for the files, GraphQL, for the GraphQL files under the glob pattern you specify. Under that particular pattern you tell them to look out for, and then you're going to store all of that types here. All right, great, cool. So now, okay, now uh, the beauty of this is that now our server, for example, when querying really nested objects, which is very easy when you use GraphQL, that our API now is organizing types and fields rather than endpoints. Okay, like RESTful architectures. So you looking at this GraphQL here, uh, from how I organize the GraphQL query for schema. So I modularized this GraphQL server for schema. I also did that with Resolver, which is another component in any GraphQL server, which you may wonder is like, what resolvers are? And the question live is on how do we query data. So GraphQL always check if a request is valid, and if it is, while executing that query, the value of the property is resolved by a function called resolver. It's determined by a code resolver. So once you define a query here, for example, when you define a query, okay, if you have multiple property, the server call the proper resolvers, and once the server has called all the resolvers, so it wrap up and send back to the front. So because doing this using the makes executable function by defining it here as as a map, or an object, is something that you can easily see that it's not scalable. Okay, because you can define it here as a query here. Then inside of that is defining all of the query capability that this server will expose, and you can quickly see that it will not be scalable. So to make our GraphQL maintainable, so I rely also on the load file sync, but this time is to look out for the resolver files. Again, splitting up our resolvers per files. You may quickly make the analogy that resolvers are like controllers in the RESTful architecture. Okay, so the resolvers here. So the resolver, you're going to export that model as an object where inside of that we'll have query, where you define is the queries you can do that. Okay, and the beauty of the resolver is that we can perform API calls, right? So here we test this using an async API call, or imitating a synchronous operation. Okay. Uh, and I also look at the anatomy of the mutation. So what you have is a parent, which is the parent is the root value they use from the GraphQL server. You have the arguments, which is used to uh, the argument is when it is used for parameterized query. For example, if you want to filter out following a particular criteria, the context is data shared across different resolvers. For example, to pass authentication data about which user log in all of your resolvers, and the info, which contains some information about the state of our application. Okay, now uh, with that, okay, uh, then I look at how can we create this parameterized query, or how can we filter query. Yeah, filtering with querying and resolvers. And again, it all starts here by defining is the query here. What you're going to pass is the argument that it needs. We said that product by price is a float type, and you require to pass that. And the return type is this product list, right? Similar as for this query, where you only want to get this one element, all right? You're going to return is a product. So here, when you look at the products, you need to define is the product resolver here, okay? And to make our application, this is part of the good practice, especially for creating applications, and to keep your query or your resolvers as thin, as simple as possible. Again, following is the high cohesion low decoupling, meaning is these resolvers are going to call the data layer access uh, from that type of data, right? So here we're calling is the data access layer function like get product by price. So in our case, we just only uses the data from in memory we define here. So we can easily see that we here is where we define this API call for any asynchronous operations. So this is the data layer, okay? Once you define is the proper functions from this layer, you then expose them for that. And that's exactly what we did. All right, and return product by price. Cool. Now, believe it or not, the GraphQL is not only for fetching data, it also allows you to update existing data. But we need to know what is the GraphQL of doing this. So to perform these crew operations that in real life applications, real life backend applications, you need to support. So with APIs, getting data and reading it is probably the most common thing you will do. And that's why GraphQL focus to do that really, really well. But again, as I mentioned, in real life backend applications, you need to perform crew operation. Create, read, which is GraphQL shines, update, and delete. So when it comes to create, update, and delete, you perform that using mutation, which after all, the name is pretty self-explanatory. It changed. Mutations mean this change. So here you're going to change the state of the app. And mutations are one of the root level operations you can perform in a GraphQL server. So you have query, which are mandatory, mutations are optional, and subscriptions. And it all comes from the specification here, spec GraphQL here. When you look at the type system, the schema here, and then you got this root operation types, the query, mutation, subscriptions, and so on. Okay. Mhm. It's funny because it is on GitHub. It is hosted on GitHub. Okay. So back here to our nodes. So we have queries and mutation, okay, as a way to build or the root level operations. Okay, so so let's go to implement a mutation here, which underneath the hood behaves quite the same as queries. And in GraphQL, we always start with our schemas. In this case, by looking at the product GraphQL, because here we're going to create two types of mutations, adding a new product and adding products review. Okay, so you got this, uh, and here in the schema, we define is the mutation. All right, uh, and we add this new product, this mutation, and passes the proper data to change the state, so that we're going to perform that operation behind the scenes. The ID, the description, we're not going to pass in ratings because we are assuming that anytime you create a new product, it has it has review, it has an empty review array and the price. So the return type is product, and this is a fairly common practice to indicate that that data was saved or that product was saved. Okay. Then you look at your resolvers, and right below here of your query, you define is or you set the mutation map or object where you describe is the mutation that you can do. Add a new product, and as this resolver function or this resolver the resolver body of this is again, since we want to keep our mutation. Okay, so what's come next is, so we are here describing this. So what is the body resolver is going to look like here? So we're going to set some function in our product model that will add a new product. So here this is going here. So we're going to set a new function that add new products to our model. Okay, and we're gonna put all the logic to create that product in our data access layer. And we're gonna put all of this logic to create a new product in our data access layer in our product.model. So to keep our resolver as thin as possible, Okay, to keep our resolver as thin and small as possible, we want these resolvers, the product resolvers, be independent, whichever model we choose to use. So we want this resolver be independent, whichever model we want to use. And this is comes here. This is starting to solve one of that issue. Okay, this is when you start to solve one of that particular issue. Here is when you're starting to solve that particular issue, the un the underfetching is that there is no need to query multiple collection of value here. You just only call a query or a mutation, and you hopefully can get the data that you want. It's like that. So it's here where all of this magic happens. Okay, so because we want to keep our resolver as flat, we want to keep our resolver as thin and small as possible. We want this resolver to be independent to be independent whichever model we choose to use. Exactly. Be independent whichever model we choose to use. Whatever database they're using and any other implementation detail. So we want to make this model to be independent to whichever model we want to use, whatever database they're using or in any other implementation details. So we want to make this model, we want to make these resolvers to be independent to whichever model we choose to use, whatever the database or any implementation detail. Okay, great, great. So we're going to pass the argument it needs this function. So you're going to pass this argument it needs this function. So this function will return the product that was added. So this function will return the product that was added. Exactly. So we're gonna right. So this function will return the product that was added. So yeah. So we're gonna pass this the argument that this function needs and return the product that was added. But how this add new product implement this function? This is when we're gonna see that right now. I already know how to do that. It's not that hard.
This function will return back the product that was added, so we'll return that value back as the result from our resolver. That's the GraphQL part. But how does our model implement this add new product function? Let's take a look in products.model.js, where we'll add a function at the bottom that we'll call add new product.
Yeah. So we are going to add a new function at the bottom called add new product.
And this function will accept our three arguments: ID, description, and price. We'll create a new product in a constant, let's call it new product, and that's going to be an object which contains our ID, the price, the description, and also we should set our reviews field to either null or better yet an empty array to show that this fresh product.
Better yet, to a null or better yet. Better yet. Okay. So we set review property to a null, or better yet, right, to a null, or better yet, an array.
So we should set our reviews field to either null or better yet, an empty array.
An empty array. An empty array.
To show that this fresh product has no reviews.
So to show that this fresh product has no review. But it's like that, it's using better.
Now, to be consistent with our pre-populated products array here, let's add an empty reviews array for each of our test products here. So reviews is an empty array, and for blue jeans, we also have reviews being empty. Back in our model function here, we'll take this new product and push it to our products database, or in our case, the in-memory list of products.
And then push it to our database, in our case, in-memory data.
New product, and push it to our products database, or in our case, the in-memory list of products. We'll take the products array and push the new product we just created. Our mutation returns back the product that was just created, so we'll return back this new product, which will come back from our model function here, back into the resolver, and finally be returned back to the client that added the product. Last but not least, we need to export our add new product function. Let's test our work. So we'll start up our GraphQL server. Here in Graphical, let's try adding a new product. Just like with queries, we can make multiple mutations, all with one trip to the server. So above our add new product review mutation, we'll add a add new product mutation, where we create a product with an ID that's, say, orange jacket, and the description is going to match our ID. So description will be orange jacket, which is going to be a bit more expensive than our shoes. So we'll say the price is $70.55. And what we'll get back from this mutation is the ID of the product and any reviews, which we decided is going to be empty. Graphical is now going to try making two mutations, only one of which is implemented in our server. Let's see what happens. We're getting back a few different errors. Notice how helpful GraphQL's error mechanism is. It's returning back everything that's wrong in all of the operations that we're trying to make. So at the bottom of our errors here, we have a message that says,
so here is this. So what I'm doing is just adding this to a Git and create a commit for that with a message add mutation, add a new product mutation. Okay, like that, and then you push those changes to that. You push to the main branch. Git push those changes to the remote repo under the main branch. Okay.
cannot query field add new product review, which makes sense because that mutation doesn't exist on the server. And it even suggests that we might have made a typo, and so this error is expected. But this first error, what's that all about? Field reviews of type review must have a selection of subfields. Of course, the reviews see what comes back now. Just the one error that we expect because add new product review doesn't exist. So we can cut this for now and try making the single add new product mutation, which works. As expected, we're getting our new orange jacket with an empty reviews array. Things are working great. Let's add back this add new product review mutation, take a quick break, and come right back to add this second mutation to our server.
Now the server is up and running. Do that again. And then you got it. Which is okay. Alright, so that makes sense on creating mutations to add new products, looking the entire
To practice writing
or the entire supply chain, the change of things that you have to do for that.
mutations. Then, towards the end of the video, we'll dive deep into how mutations are executed and how to execute many mutations all at once. Let's get to it. Based on the add new product mutation, to this opportunity to practice writing mutations. Then, towards the end of the video, we'll dive deep into how mutations are executed. Welcome back. Let's take this opportunity to practice writing mutations. Then,
So this is exercise adding new product. Perform the mutation here. So in our GraphQL, in our graphical, localhost, you send this, and then you get that data. And you should get is you will get this data. Okay, now here the exercise add new product review. Okay. Add new product review.
towards the end of the video, we'll dive deep into how mutations are executed and how to execute many mutations.
Okay. So we're going to practice. We are going to practice how to write mutations in
We'll dive deep into
dive deep
how mutations are executed
and then dive deep how mutations important is how mutations
and then, towards the end of the video, we'll dive deep into how mutations are executed.
Exactly. How dive deep how mutations are executed
And how to execute many mutations all at once.
and how to execute many mutations all at once. Okay.
Let's get to it. Based on the add new product mutation that we just created, see if you can implement a mutation to add a new product review to an existing product. This mutation can return back either the new review object alone or the entire product with its newly added review. Pause the video, give this a try, and then let's go over the solution. How did it go? Ready? This mutation can return back either the new review object alone or the entire product with its newly added review.
If you're going to add a new product review, it makes more sense to return the product with this new updated review.
Pause the video, give this a try, and then let's go over the solution. How did it go? Ready for the solution? We start with the mutation type, adding the name of our mutation. So let's be clear and say add new product review. And we already mostly decided how this mutation will look earlier in this section. We need to associate a new product review with an existing product So we'll say that the review is associated with the product with some ID that we pass in as the first argument. And then our review must have a rating, which is an integer, as we see below right here. And we have an optional comment, which is a string. For the return value, let's just have our mutation return back the newly created review object. There we go. Now in our growing products resolvers file, underneath our add new product mutation, we'll add a mutation field matching our schema. So add new product review. And again, we are ignoring the first argument, but making heavy use of the args, which include all of the data for our review. We're going to be calling some function in our products model that we'll call add new product review, passing in the ID of the product we're reviewing, the rating for that product, and optionally, a comment for our review. This model function will return back the review we just added so that our mutation can send it back to the user. Very similar to our original mutation. Now in products.model.js, we'll add our function to add new product review, which accepts the product ID, rating, and comment. And here things get a little bit more tricky. We first need to find the product that matches this ID so that we can add the review to the appropriate object. So we're going to use the find function on our products array to find the matching product that's being reviewed. In fact, we need exactly what our getProductById function is already doing. So we'll make use of this function inside of add new product review. We'll create a new constant for the matched product corresponding to the ID being passed into our mutation, and we'll set this matched product to getProductById using that argument, so ID. Now if a matching product isn't found from the find function, the result will be undefined, which we should check for so we don't try to add a review to a product that doesn't exist. So we'll say if matched product, then we'll create a new product review constant with the data that was passed in to our resolver. So this is going to have the rating as well as the comment if it was set. Finally, we'll add this new review to our matched product. So we'll say matched product dot reviews dot push, passing in new product review. We could check if reviews is not undefined or null, but we know that the reviews are always being set to the empty array for new products. So for our example here, we'll be a little bit less safe, but keep things nice and short. Finally, we'll return back that new product review if there was a new product review. We could check if reviews is not undefined or null, but we know that the reviews are always being set to the empty array for new products. So for our example here, we'll be a little bit less safe, but keep things nice and short. Finally, we'll return back that new product review if there was a matched product, and undefined if no review was added because no product matching that ID exists in our data model. We can't forget to export our new function right here at the bottom of our file, and we should be good to go. Our model, our resolver, and our schema are all in place, which means we can test some mutations. We'll make sure our server is running with the latest changes. Now in GraphQL, we can make as many mutations as we need, adding any new products that we want with any product reviews. Let's do 2 reviews as part of this mutation. We'll do one for the red shoe, and then I copied this over, and let's do one more for the orange jacket. Let's make the orange jacket review a 4-star review out of 5 with a comment that says, this jacket is very warm and very orange. All right, so we have 2 product reviews and 1 new product, all being wrapped up together as part of this single trip to our Node GraphQL server. But you may notice that GraphQL is underlining our add new product review mutation here and saying that these 2 similar mutations at the bottom of our screen here are conflicting with each other. Why is this? Well, think about the response that we'll get back in GraphQL, the response from our GraphQL server. We'll have 2 add new product review mutations, each getting a rating, but they're 2 different mutations. And they're going to be under the same add new product review data object in the response. There's a conflict. What we need to do is add an alias to each of these conflicting mutations to differentiate between them. The way we do this is by adding a name in front of the mutation. For the first one, let's call it shoe review, followed by a colon. And for the second one, let's call it jacket review. Just like that, we've set up two aliases to differentiate between our mutations. Let's see what happens. Very nice. We got a new product that originally had 0 reviews. This makes sense because GraphQL executes our mutations one by one in serial and not in parallel all at once. So first we add this new product, and only then do we add the reviews once the response to our add new product has already been set. So after add new product, the product review was added for our red shoe and then for our jacket. And we're getting back the ratings for both reviews. Great stuff. Now we can make a query to get all of our products, specifically getting the description and any reviews, including the rating and the comment of each review. After our mutations, let's see what comes back now. Beautiful. We're getting our red shoe with our 5-star review. We're getting back our blue jeans. And finally, the new product that we added, along with the review that was added separately after the jacket was already added. We now have the ability to create, read, or update data, all with GraphQL's query language. All right, we're ready to move on to the next video.
That's interesting, though.
I'll see you there.
Very, very interesting.
Welcome back. We've been building our server and feeling really good about our GraphQL. But someone comes along and asks if we know Apollo. And can we work on an Apollo GraphQL project? We pause for a second, but we remember that we're ready for this. All right, what's the first thing that we need to know? Well, what exactly is Apollo, and how does it relate to what we already know? Apollo is another GraphQL implementation, very much like Facebook's reference implementation that we've been using so far. However, Apollo is much larger with more features. It has all of these different libraries to make GraphQL queries and save GraphQL data in React on iOS, as well as Android. There's a server component, which is a replacement for Express GraphQL. It works very similarly, but adds some extra features if you need them. And there's a few more advanced tools that the Apollo team has built if you really want to commit to their platform that help you build Apollo projects as part of a much larger team. But the two main components of Apollo that you'll see in your development career are this Apollo server and the Apollo client, which is where we'll start because the client is where Apollo's benefits really shine. Apollo Client is a set of front-end libraries that help make GraphQL queries and save GraphQL data in your front-end. Using Apollo is much more convenient than making POST requests to your GraphQL endpoint on your server directly. It lets you query your GraphQL server with your front-end application much like you would through Graphical. And it comes with added benefits like caching your queries, handling loading states and errors, and keeping your data synced with the server. It makes the data that you fetched available to your front-end components, whether you're using React or Angular on the web, iOS, or Android. It handles connecting your components with the data that comes back from a GraphQL query without having to hook things up manually. That's Apollo Client. What about Apollo Server? Apollo Server is its own package on GitHub, which allows you to create a GraphQL server in Node, very much like our Express GraphQL package. But Apollo Server can work with Express or Koa or pretty much any other popular Node framework. Even better, it helps you run and deploy your GraphQL code to serverless environments, like Amazon's Lambda service on AWS. And it includes functionality to help implement subscriptions in your server. Subscriptions are the third type of GraphQL operation. We had your normal read queries, we had mutations, and we have subscriptions, where subscriptions allow you to push updates from the server to subscribing clients, much like push notifications on your phone. Subscriptions are a very advanced GraphQL topic that's needed much more rarely than mutations and queries. Now, all of these things are possible with Express GraphQL, that package that we've been using so far. But Apollo Server wraps up all of this functionality into your GraphQL server and exposes it individually in a set of NPM packages. There's this page on the Apollo GraphQL website which explains how to choose the right package for you. We have the batteries included Apollo server package that includes just about everything, but then we can choose some different options. There's Apollo server, but there's also Apollo Server Express, which allows you to use Apollo server in an existing Express API. This is the most widely used version of Apollo server. But we also have serverless specific packages, where we can run an Apollo server on AWS Lambda, or Google's offering, Google Cloud Functions. And there's plenty of other options for other Node.js frameworks, whether it's Koa, Happy, or Fastify. The good news about all of Apollo's extra features is that they have this excellent website right here. If I zoom out, we can see that it has this really excellent documentation on all the different features of Apollo, regardless of which aspect of it you're using. And the even better news is that when it comes to Node and the backend, Apollo will feel quite comfortable to us with our experience so far. The server-side component is very close to the GraphQL code that we've been building. So let's keep it going and see Apollo server in action.
Fastify. Fastify or Happy. Stack share. Yeah, but all of them follow that particular trend. Micro framework package.
It to the people, the document is that they have this
in color. Next assignment. So battery for skill query and schema loader for Postgres. Next. You're going to rely on broadly. According to Reagan. Raw HTTP node. Oh shit. Average request per second per frame. Ah, but this is 2016. What about something more new? I don't know. Is here. Well, but okay. All right. So with that, I'll see you in the next episode. Take care. Bye bye.